Let A be the non-singular square matrix of order 3 by 3. Then det of adjoint A is equal to. This is a question. Okay, so we have the formula. We have the formula. Okay, so in the same exercise in question number 3 and 4, we discussed the formula. Okay, so adjoint A into A, adjoint A into A is equals to A into adjoint A, that is equals to det A into IN or det A into I. Okay, already we discussed this. Okay, so we know that adjoint A into A is equals to det A into I. Adjoint A into A is equals to det A into I. Okay, so now this is equals to det A into, this is equals to det A into, okay, I. What is I here? Okay, since it is a 3 by 3, okay, so 1 0 0 0 1 0 0 0 1 0 0 1. It is the identity matrix of 3 by 3. Okay, now if you multiply inside, then det A into 1 is det A. Okay, so and 0 and 0, here this 0 as it is, and here we get det A and 0, here 0, here 0 and det A and det A. Okay, so this is the matrix here. This is equals to adjoint A into A. Now the question is related to determinant of adjoint A. Now I am taking the determinant. So determinant of adjoint A into A. Okay, so is equals to, here also we have to take the determinant. Okay, so inside all again det A 0 0 and 0 det A 0 det A 0 and 0 0 det A 0 0 det A. Okay, so now okay, so already I told you the properties. Okay, at present we don't have the property based questions, but according to the properties of determinants, okay, so we can take the det A common from either one row or one column. Okay, so here from this row, okay, so we can take det A common. Okay, so then we get 1 0 0. Okay, again second row we can take one more det A common. Okay, this is from second row, and then we get 0 1 0, and one more det A we can take common from the third row. Okay, so that means it becomes 0 0 1 0 0 1. Okay, so that is nothing but det A whole cube into 1 0 0 0 1 0 0 0 1. Okay, for that we take the determinant, and if we take the left side part we can separate the determinant. That means det of adjoint A into det A, Okay, so here det of adjoint A into det A is equals to det A whole cube into, okay, I. What is the determinant of I? Determinant of I is 1. Okay, so that means we get det A whole cube. Okay, so is equals to adjoint A into det A. Okay, det of adjoint A into det of A is equals to det A whole cube. Okay, so here take this det A to that side. Now det of adjoint A, determinant of adjoint A is equals to, okay, determinant of A cube divided by determinant of A. Okay, one determinant of A gets cancelled, so finally we get determinant of adjoint A is equals to det A whole square. What we get here? Det A whole square is the required final answer. Understood? Yes. Okay, so here in this question, so A is given as non-singular. Non-singular means determinant is not equal to 0, and it is a 3 by 3 matrix. Okay, so then he is asking determinant of adjoint A. Okay, So now already we have the formula. Okay, so what is the formula here? This is the formula. Okay, adjoint A into A or A into adjoint A is equals to det A into I. Det A into I or IN or I2, I3. Okay, here it is equal to I3. Okay, so now here det A I am writing as it is, and I identity matrix. So I written identity matrix means 1 0 0 0 1 0 0 0 1. Okay, so after that multiplying inside with the det A. Okay, det A into 1 det A, so 0 0 as it is. Again here we get det A and here we get det A. Okay, the remaining all are zeros only. Okay, so now here I am taking the determinant. Okay, applying determinant on both sides. If we apply determinant on both sides, we get the determinant for left side and determinant for the right side matrix also. Okay, so after that in the determinant, according to the properties of determinants, we take the element common from any single row or single column. From first row we can take a det A common. From second row we can take a det A common. From third row also we can take det A common. So means row wise or column wise I am taking det A common. Okay, so here one det A, here one more det A, here one more det A. Total we took 3 det A common from the 3 rows or 3 columns. Okay, after that this becomes det A whole cube, and it is identity matrix 1 0 0 0 1 0 0 0 1 is the identity matrix. Okay, and determinant of identity matrix is equal to 1. Okay, already you know how to expand this. Okay, so if you want you can write here. Okay, so since we can write determinant of I is equals to 1. Okay, so that means no need to write here. So here and the determinant of adjoint A into determinant of A. So I am taking this determinant of A to that side. Here it is multiplying. If you take it to that side, divide. Okay, det A whole cube by det A, and one det A gets cancelled. Okay, so then we get det A whole square. Then we get det A whole square. Okay, this is only the required solution. Understood? Understood, ma? So do you have any doubts more in this?
Sir.
Okay,
No,
so
sir.
now we'll go to the next question here. Okay, if A is an invertible matrix of order 2, then det of A inverse is equal to So already we have the formula, we know the formula. Okay, so we know that A into A inverse is equals to I. A into A inverse is equals to I. I am taking the determinant on both sides. Okay, so then we get det of A into A inverse is equals to determinant of I. So we can separate this determinant. Okay, so here determinant of A and the determinant of A inverse is equals to determinant of I. Already just now we discussed the value is equal to 1. Okay, determinant of I is equals to 1. Okay, and what he is asking the determinant of A inverse. Okay, take this det A to right side. Here it is multiplying. If you take it to the right side, divide. Okay, 1 by det A. Okay, determinant of A inverse is equals to 1 by det A is the required solution. What is the final answer? Therefore, okay, so he asked the question like this: det of A inverse is equals to 1 by det A. Okay, so this is the required solution. Okay, so what option is correct? Option B is the correct answer. Okay,